Hey, welcome to another video of Wise Interactive Learning. In this video, we are going to cover all the concepts of continuity in just one take. But before I go into that, I'll ask you a question. Have you ever played a game like PUBG or listened to it? Well, take a look.
In the lead. Dead! Cover me!
Well, if you took a look at that video, my question to you is, did I fire continuously at the opponent or I did not? The answer is no, I did not fire continuously. But if you put that on a graph, what would it look like, right? So the answer is right over here. Well, if you plot the graph of it, on the y-axis there will be bullets, which is 40 at the start of the video. Then I fired for some time, which is for 2 seconds, and the bullets came down to 20. And on the x-axis we have the time, so at 2 seconds, 3 seconds, 5 seconds, and so on and so forth. So is this graph continuous? Well, we'll take a look. If we have to draw, we'll go at 40 and we'll mark it over here, and we'll come down till 20, and we have to pick a pen, and then we again have to draw from 20 up until 3. Well, what's the point over here? In layman's term, we can say that if you pick your pen up from the board while drawing a graph, the graph is discontinuous. In this video, we are going to watch everything regarding continuity. Take a look. Welcome back everyone. So in this video, we are going to discuss 3 different topics, which is what is continuity, what is discontinuity, and what are the 2 types of discontinuity. So I'll take a point. In this case, the function is y equals to f of x, and the x-axis we have the value of 2. So at this function, if we plug in the value of 2 over here, the function y will become as f of 2. So we'll see how can we define continuity. So mathematicians are very smart people, right? And what they said was, in order to get to this value, we can go from 2 ways. First is we can go from left side, and in the second way, what they said was we can go from the right side, which is this, right? And they said that if all these points corresponds to equality, then we can say that the graph is continuous. And what do they mean by this? So let's say from left side we have the limit x going towards 2, which is from left side we go towards 2, f of x, because the function is f of x. If this is equal to limit x tends to 2 f of x. Well, there's some confusion over here, right? Well, these and these are the same things, but actually they are coming from different sides. So how are we going to denote them? So what they said was, if they are coming from the positive side of the x-axis, let's take this as 2 plus, and let's take these values as minus. So in this case it can be 1.99, or let's say in this case it can be 2.01. And what they said was, if these 2 values are equal to f of 2, then the function is continuous. Well, I'll explain what they mean. What they mean was, if you come from the left side and if that value is equal to f of 2, and if you come from the right side and if that also value is equal to f of 2, your graph or the function is continuous. That's it. Well, in general form, how can we write it? We can write it as limit x tends to c negative f of x is equal to f of c, which is equal to limit x tends to c positive f of x. And that's your continuity. But let's go back and rewind ourselves to the PUBG problem, right? And we said that, well, this graph is discontinuous, right? And we'll check if it is continuous or discontinuous. So we'll go at a particular point. Let's take 2. So we have 2 cases, which is we have 1.99 and 2.01, right? So we'll write limit x tends to negative, which is from the left side, f of x and limit x tends to 2 from the positive side of f of x. Well, now we know that this is for 2.01 seconds and this is for 199 seconds, 1.9. Now please tell me, is the graph at 2.01 existing? Can you tell that at this particular point, which is 2.01, is the graph existing? Well, the answer is clear no. Since these are not equal, you can say that, you just can rub it off and you can say that these are not equal, which is why the graph is not continuous. In this case, because at 2.01 I am not firing the bullets, so this graph is not continuous. Well, you can see it over here. But if we change that problem a bit, what we'll do is, we'll look if the graph is continuous at 1.5 seconds. And what can happen is, we'll just rub this off. So now you can see that I have just magnified this graph over here. So at 1.5 seconds, we need to check if the graph was continuous. Well, let's take this. So if from left side, from the negative side and from the positive side. So from negative side, we'll take 1.49 second, which is very close to 1.5, and from positive side, we'll take it as 1.51. So limit x tends to 1.5 from the negative side of f of x will be equal to f of 1.5, which will be equal to limit of x tends to 1.5 from the positive side of f of x. Well, why are they equal? Because at 1.49 was I firing? Yes. At 1.5 was I firing? Yes. And also at 1.51 was I firing? Yes. So the continuity of the function from 0 to 2 is that the function is continuous. What I mean by this is, this whole function from 0 to 10 is discontinuous. But in case of 0 to 2, this function is continuous, and this is called as continuity of a function over a domain, which means that in a particular domain from 0 to 2, which is 0 over here, from 0 to 2, this function is continuous, but from 0 to 10, this function is discontinuous. That's it. So we'll generalize what is discontinuity in the formulative way, and we'll make sure that we have clear the concepts of what is continuity and discontinuity before moving on to different types of discontinuity. When limit x tends to c from the negative side of any f of x, if it is equal to f of c, which is also equals to x tends to c positive side of f of x, if this condition is satisfied, then the graph is continuous over that domain. If given. Well, what does this mean? That if the conditions are given, if the boundary limits are given, then over that domain, if these conditions satisfy, then the graph is continuous. Well, in another case, if these are not equivalent to each other, or let's just say that for some reason that this particular f of c does not exist, or this does not exist, or this value does not exist, then you can say that this graph is discontinuous. Again, over the domain and the range of the particular graph. So these two conditions satisfy. So why am I giving these domains? Particularly because when you find any question, what will happen is, when they give you certain functions, they will give you a domain range, which is basically from 0 to 2 or less than or equal to 2, from 2 up until 5, from 5 up until 8. So in these situations, what you'll find is you need to specifically know at this particular point the graph is continuous or no. So we'll take a look what are the discontinuity of a function and what are the types of it. So we take a look at what are the two types of discontinuity. So we know that if we come from the left hand side, it is called as the left hand limit. If we come from the right hand side, it is called as the right hand limit. So in this case, if you watch carefully, the value of function y equals to f of x at 2 is 8 and it is not matching with the left hand and the right hand limit. So what we can do is, if we can redefine the function at f of 2, then this function is known as discontinuous function with removable discontinuity. But why is it called that? Because we can redefine this value as f of 2, which is, we can just shift this point towards down and we can say that this point is called as f of 2 for that particular x equals to 2. But in this case, if we look at it, this function is nothing but greatest integer of x. So at any particular instance, if we shift this point over here, then still this graph would have a cut over here. So at every instance, you cannot change the graph and make it continuous. Thus, this graph is known to be as irremovable discontinuity. So these are the two different types of discontinuity which you are going to learn. Well, we have cleared up all the concepts of continuity, discontinuity, and what are the different types of discontinuity. In the next video, what we are going to watch is the examples taken completely from your exercises books. So first we'll complete all the exercises from 5.1 chapter of this book, and the exercises is 5.1, and later on the same day we are going to solve all the exercises from this book, which is the first chapter, which is the exercise 1.1. So we are going to cover up all the exercises question in just 3 videos, which is 1.1, 1.2 and the remaining entire in the one video. So make sure that you share this video on your WhatsApp channel, join the Telegram group, the link is in the description below, and make sure that you comment on this video what else do you want to learn from my channel. Take care and see you in the next one.